Hey guys, for my problem presentation today I'm going to do from chapter 10.3. It is the question as I've given there. Determine the upper interval t interval on which the curve is concave downward or concave upward. We have given x equals to sin t and y equals to cos t. So here is the solution here. So to find the concavity, we need the second derivative of y with respect to x. So first we did dy by dt equals to minus sin t and dx by dt equals to cos t. And after that, dividing minus sin t upon cos t equals to minus tan t. You know that, right? Now take the derivative of that with respect to t for the second derivative. So while taking derivative of this, we get minus sec square theta. Sec square t. Now we use the second derivative formula on here. Second derivative formula, you can say that d square y upon dx square equals to d upon dt, dy upon dx divided by dx upon dt. So we have the derivative of this is minus sec square t, so we put minus sec square t, and then we get minus sec square t upon, this is minus sec square t upon cos t. So that means minus sec square t. We analyze the sign of d square y upon dx square to determine concavity. So when dx square upon dx is less than 0, the curve is concave downward, and if this equation is greater than 0, it is concave upward. So by focusing on the sign of the second derivative, we get this, right? So we look at the sign of cos t, then we look sign of cos t, and from 0 to t between pi by 2. So cos t is greater than 0, so it's concave down. So cos t is less than 0, so it's concave upward. We know that, right? And this is our final answer. The concave upward is pi by 2 comma pi, and concave downward is 0 and pi by 2. This is the presentation for problem 10, chapter 10, and I'm going to show now for chapter 11. I have a question here, and for my chapter 11 I have this question out here. It's a problem from chapter 11.2, question 12. We have given here complete the square to write the equation of the square in standard form. So I have the same question here. I already solved this, and I'm gonna explain it well. So it asks us to write the equation of a sphere in standard form by completing the square, and then find its radius and a center and radius. So we have given the general form of the equation. Here is the general form of the equation, and at first we move the constant to the other side. So x square plus 5x plus y square minus 2y plus z square plus 12z. I put them in a same bracket. Now we group the term of this variable so we can complete the square. For x square plus 5x, the half of 5 is 5 by 2, square that is 25 by 4. So x square plus 5x equals to x plus 5 by 2 square minus 25 by 4. And for the Similarly for the y square minus 2y, so I have done this same as before. Minus 2 is minus 1, square that is 1, so this is the y square minus 1, whole square minus 1. So for the x square plus 12z, half of 12 is 6, square that is 36. Z square plus 12z equals to x plus 6 whole square minus 36. Now we plug them back in the equation. So after we plug them back on this equation right here, we get this in a long form, right? Now we add all the constant in here. So we have the constants minus 25 by 4, minus 1, and minus 36. In the total, it will be 173 by 4. So the equation become this in the last, right? For the full answer in standard form is this is the standard form of this equations. So for the center and radius, we have this radius. This is the radius, and we put on the root. And for the center, we have minus 5 by 2. Here is the plus 5 by 2. We change the opposite side. So this is the minus 5 by 2. It's a minus 1. Here is 1. Here is a minus plus 6. Here is a minus 6. For this, we get the center also. We get the radius. And this is the final of my problem. Thank you for watching.